Hello and welcome to Mrs. Law's class. In this lesson, we're going to take a look at three power rules: the power of a power rule, the power of a product rule, and the power of a quotient rule. So in the first power of a power rule, when you have a power to a power, which simply means that you have a power raised with another exponent, the base will stay the same and the exponents are multiplied. So here we have a to the power of m to the power of n. So what happens is the base stays the same, and we take our exponents and we multiply them together. The reason that they're multiplied is because we have n groups of a to the m. And then we have to also remember that a can't equal 0. So let's take a look at three examples. So write these powers as a single power. So right now they all have two exponents. So in the first one, we have a base of 5, and our exponents are 3 and 7. So we're going to multiply 3 times 7, or if you want, you can go straight to 5 to the power of 21. In the second example, our base is -2, and our exponents are 3 and 4, so we're going to multiply 3 times 4. So now we have -2 to the power of 12. Now, often you will see that with even exponents, if we have an even exponent and the base is negative, because we know that there's an even number of negative signs, we can actually rewrite this as 2 to the power of 12 because we know that our answer will actually be positive. Now, in the last one here, the negative is on the outside and the 5 only surrounds the 6 and the squared. So notice the brackets are around the 6 squared. So I'm going to bring down the negative, and I'm going to write this as 6 to the power of 2 times 5, or I can rewrite this as -6 and then to the power of 10. And notice that the 10 only applies to the 6, and there's no brackets around the negative sign. So the 10 is only being applied to the 6 again. Next, we're going to take a look at the power of a product rule. So when you have a power of a product, that means that we have an exponent and our bases are two values multiplied together, which is a product. The exponent outside of the brackets, in this case we can see there's an m, is applied to the exponents on each factor inside the brackets. So here we can see that there isn't really an exponent, but we can pretend that the exponents on a and b are 1. So this would be expanded to a to the power of 1 times m, which is m, times b to the power of 1 times m. So it's imagining that we have little 1s over here, which usually are not written down. So again, a cannot equal 0, and b also cannot equal 0. Now, what I want to do next is to evaluate each of these examples here in two different ways, using the power of a product rule, and then also showing you BEDMAS, and then we're going to compare the two answers. So method 1 is we're going to use the power of a product. So we can see that we have two bases, 3 times 5. It's all surrounded by the brackets with a power of, or an exponent of 2 on the outside. So this is 3 to the power of 2 times 5 to the power of 2. Okay, we're going to evaluate each part or each exponent separately, or each power separately. So 3 squared is 9 times 5 squared, which is 25. And then 9 times 25 is 225. Now the second method is to use our order of operations. So order of operations tells us that we're going to do the brackets first. So in this case, it's 3 times 5, and that's 15, which is still in brackets because we're only doing what's inside the brackets. And then we have a power of 2, and then 15 to the power of 2 is also 225. So you can see that whether we use the power of a product rule or we use order of operations, we actually still get the same answer. So let's try another one. So here we have -2 to the power of 3 times 10 to the power of 3. So applying the exponent 3 to both the base -2 and the base 10. Now we have negative 2 cubed, which is negative 2 times negative 2 times negative 2. So that is negative 8 times, and then 10 cubed is 10 times 10 times 10, which is 1,000. So now we get negative 8,000. Method 2, using the order of operations, we're going to multiply the negative 2 times the 10 first, and that would give us negative 20, and then that's cubed. And remember, this means negative 20 times negative 20 times negative 20. So we know that negative 20 times negative 20 is positive 400, and then positive 400 times negative 20 will also give us negative 8,000. Same as our method 1. Lastly, let's take a look at the power of a quotient rule. So the power of a quotient states that when you have a power, which is the exponent of a quotient, means that we're taking two values and we're going to divide them. The exponent outside of the brackets is applied to the exponents on the numerator and denominator of the fraction inside the brackets. So that means we would have a to the power of m divided by b to the power of m. And this is actually very similar to the power of a product, where m was applied to both of the bases there, and here m is applied to kind of both of our bases because we have a fractional base. And remember that a cannot equal 0, and b also cannot equal 0. All right, so let's apply the power of a quotient rule to a couple of examples, but we'll also contrast this with BEDMAS again. So in method 1, we're going to use our power of a quotient rule. So here we have division. This time I didn't write it as a fraction, but with a division symbol. So we still do the same thing. We're going to have negative 36, and this will be to the power of 2 divided by 4 to the power of 2. And this is going to be a huge number, so negative 36 squared, we can go to our calculator, and we get 1,296. Remember, it's going to be positive because we have negative times negative, and that's divided by 16. And again, we'll go to our calculator, or you can do some long division, and we get 81. All right, let's try method 2. Method 2 is to do our order of operations. So we're going to do the negative 36 divided by 4 first, and here we get negative 9. And then that's going to be squared. And this one we actually can do without a calculator. So negative 9 squared is going to be positive 81. So you can actually see here that it makes it easier to actually do the division first because we'll get a smaller number before we square. As opposed to if we square each of the numbers separately, we'll get a bigger number divided by another maybe big number, which might be hard to do in our head. So let's take a look at the second one to see what happens. So method 1, we're going to apply the power of a quotient. So we get 24 cubed divided by 6 cubed. And this one we definitely need to go to a calculator. So 24 cubed is 13,000 actually. 824 divided by 216. And actually 216 does go into 13,824, 64 times. So method 2 is to do the order of operations. So we'll actually do the division first. So 24 divided by 6 is 4. And then we have our power of 3. And 4 cubed we can do in our head, and that's 64. All right, so we'll finish off this lesson with a word problem. So a path 2 meters wide is to enclose a circular lawn that has a 25-meter radius. What will be the total cost of the material for the path if the cost per square meter is $3? All right, so let's begin by drawing a picture. So we have a circular lawn, so we should draw that first. And then we have a path that is 2 meters wide. So the path also has to be circular. Since it surrounds our existing garden. Make it a little bigger here. Okay. All right, so let's label our garden, and that's going to be, it says it has a 25 meter radius. Now I didn't draw it to scale, otherwise this would have to be really big. So this is 25 meters from the center to the outside, and then we have a 2 meter path. So this doesn't look like 2 meters, but we don't have a lot of space, and I want to be able to draw both the lawn and the path. So the question says, what will be the total cost of the material for the path? So the path actually is this outside edge over here, which I'm going to color in yellow so that you can see. So to find this yellow path, or the area of this yellow path, we need to find the area of the bigger circle and then subtract the area of the smaller circle, and then we'll have the area of the highlighted part. So recall that the area of a circle is pi times r squared. So the area of the path, and I'll put a little, what we call a subscript, a little bit smaller, is equal to the area of the big circle minus the area of the small circle. Okay, and then when we want the cost, we then have to times it by the $3. Okay, so let's do this part first. So we have pi times the big circle, and the big circle is going to be 27 squared, because we need to add the radius of the smaller inside circle plus the 2 for the path, and then we're going to minus pi times the smaller circle is 25 squared. So here we have 729 pi minus 625 pi, and when we subtract that, we get 104 pi. And then to find the cost, we take our $3 for the square meters, and we're going to times that by our area of 104 pi. Now I've kind of just left it as pi, but what we're going to do is when we use our calculator, make sure you use the pi button on your calculator, or type in as many digits for pi as you can. So multiplying 3 times 104 times pi, we get a cost of $980.18. So you can write the material will cost $980.18. And that's how you solve a word problem that involves exponents.